Hello, I'm Brian Young, and today we're going to be talking about hand tools, Module 00103 in the core curriculum book. So let's get started. Introduction to hand tools. After completing this module, you should be able to name common hand tools and state how to use them, identify various hammers, demolition tools, describe chisels and punches, match screwdrivers to the appropriate hardware, differentiate between non-adjustable, adjustable, and socket wrenches, describe various types of pliers, identify common measurement layout tools, and describe how to use them, identify and describe other hand tools common to the shop and job sites. And there's a performance task your instructor is going to have you look at, identify, and use properly 5 of these tools. So every profession has its tools. A surgeon uses a scalpel, an instructor uses a whiteboard, an accountant uses a calculator. Construction crafts require a broad array of hand tools. Even if you're familiar with some of the tools, all craft workers need to learn how to select, maintain, and use them safely. A quality hand tool may cost more up front, but if it's properly used and maintained, it will last for years. A true craft professional invests wisely in hand tools and uses, maintains, and stores them with the same wisdom. Common hand tools. Let's take a look at the common hand tools here. I have no highlights. This section presents common hand tools used in construction crafts, including hammers and demolition tools, chisels and punches, screwdrivers, wrenches, pliers, and wire cutters. A lot of times you'll go into an existing building that they're remodeling. That's where demolition comes in. Sometimes you have to determination. You take out receptacles, lighting fixtures, what have you. Sometimes you'll turn off a circuit, pull out the wire, and remove the piping. A lot of times after you disconnect the power and take the wires out, they'll just come in with sledgehammers, take the wall down, depending on what the wall's made out of. In the construction environment, some personal protective equipment must be worn consistently on the job site. This includes safety glasses, safety shoes, hard hats, and gloves. This protective gear is typically required on every job site for your protection. Take care of yourself. Take care of your body. Don't overreach, don't overstretch, don't lift anything that's too heavy for you. Wear your PPE. Wear your safety glasses. You don't want to lose an eye. Wear gloves if you're moving anything that's sharp or jagged. And by all means, get yourself a good pair of work boots, preferably with either a steel-toed shoe or a composite toed shoe to protect your feet. Hammers and demolition tools. Claw hammer. The claw hammer typically has a steel head and a handle made of wood, steel, or fiberglass or graphite. Claw hammers are generally associated with carpentry and similar crafts. The head is used to drive nails, wedge, or dowel, and the claw is used to pull nails out of wood. Dowel, it's a pin or rod, usually round, that fits into a corresponding hole to fasten or align two work pieces. There's a difference between a carpenter's hammer and an electrician's hammer. The electrician's hammer has a straighter claw. If you see a carpenter's hammer, it's going to have a claw that looks almost like a quarter circle. And it's more for pulling nails or pulling apart pieces that have been attached together. The electrician's hammer has a straighter claw. What I'm told is we used to notch the wood studs to get our wire in, and you'd use that claw to make a notch in the wood. Milled and smooth nailing surfaces. This is a waffle-headed hammer, and a lot of times when you hit the nail, you'll see that waffling transferred to the head of the nail. There are several common types of claw hammers. Finish hammers are designed for lighter work, such as finish carpentry, as the name implies. They're well suited for driving slender nails without overstriking or bending them. Overstriking is when a hammer misses the head of a nail with the head going past it and allowing the hammer handle to impact the nail head instead. Overstriking is a common cause of hammer damage. So, like anything, takes practice. The more you do it, the better you're going to get at it. So, start practicing now. Framing hammers. Here's a framing hammer. Usually your hammers for carpenters are heavier, 21 to 26 ounces, but you're going to be carrying it on your tool belt, so you don't want to go ridiculous. You don't want a 32-ounce hammer. That's close to a 2-pound sledge. You don't need that. Curved claw and rip claw hammers. That's that curved claw that I was saying is more indicative of a carpenter. This straighter claw is more indicative of what an electrician would carry. But it's all in preference. Use them, decide what you like better, carry that. Driving a nail with a claw hammer is a simple, using the following techniques. Although practice is required to develop rhythm and accuracy, don the appropriate PPE, including safety glasses, hold the nail in position and rest the hammer, the face of the hammer on it to give you a visual starting place. Draw the hammer back and lightly tap the nail to start it. Once the nail is started, move your fingers out of the way. Hold the hammer level with the head of the nail, using the motion of the wrist, elbow, and shoulder to strike the nail squarely in the center of the hammer face. If your hammer face is not flat with the head of the nail, if it's leaning to one side or the other or forward or back, that's going to bend the nail. And a lot of professionals get to the point where they can drive that nail straight the first time, or if it does get off kilter, they can counteract that. They can compensate for that by rolling the hammer so that it's going to strike the face in such a way that it's going to straighten that nail back out. When you're in class, your instructor will demonstrate that for you. They'll show you how to do that. Did you know? It says when it comes to tools, it pays to invest in quality equipment. The strongest and safest hammers have heads made of a tough alloy, a mixture of 2 or more metals, and or drop forged steel. I'm going to highlight that. I think that used to be a highlight, that they're made out of drop forged steel. That's what you want in a hammer, drop forged steel. Here's a carpenter's hammer. It actually has, it's magnetized, so it holds the nail in the hammer. You don't have to hold it with your hand, and you can strike it and get it to start, and then you can finish putting it in with the hammer head. Let's see what it says here. It says the hammer is designed to produce a certain amount of force on the object it strikes. If you hold the hammer incorrectly, the benefits of its design are not evident. The distance between your hand and the head of the hammer affects the force you apply to drive the nail. The closer to the head you hold the hammer, the harder you will need to swing to achieve the desired force. Hold it with the end of the handle, even with the lower edge of your palm. Make it easier on yourself by holding the hammer properly. It takes less effort to drive the nail. If you're doing a lot of hammering, if you're going to go into the carpentry trade, then you're going to want to protect your wrists. You don't want to get carpal tunnel. You don't want to get damage of the tendons in the wrist. So you learn to strike with the hammer, but at the last second to kind of loosen your wrist so that the hammer can bounce. The hammer's going to bounce off that nail. If you try to resist that bounce, that's when the shock is going to be absorbed by your body instead of the hammer. Okay. And again, practice makes perfect. It takes a while. Pulling a nail with a claw hammer is as easy as driving one. Slip the claw of the hammer under the nail head. Use the leverage of the hammer to pry the nail up till the hammer's handle is nearly straight up, partially drawing the nail out of the wood. Try to pull the nail straight up from the wood. If it's too tight, more leverage is needed. Place a small block of wood between the hammerhead and the wood elevated. Then repeat the prying motion. I do this a lot with my side cutters. I'll pull a nail partially, part of the way out, and then I'll take my side cutters out of my pocket and put it underneath the hammer claw or the head of the hammer. So it gives me a little bit more leverage to pull that nail all the way out. Drywall hammer. This is a highlight. It says a drywall hammer is used for driving nails in drywall, also referred to as sheetrock. Let's see, what does it say? Oh, get out of there. Trying to get to my, it won't see there. All right. I've got this highlighted and it shouldn't be. Let me see if I can take it out here. If I can click on this and take it out. Delete highlight. There we go. Now I can say a drywall. Large flat board made of layers of fiberboard and gypsum, used primarily for wall construction and finishing. Drywall, also known as sheetrock and wallboard, is typically manufactured in 4x8 panels and readily accepts paint. Okay. I'm gonna re-highlight most of this sentence, but I'm gonna leave the drywall not highlighted so that I can click on it and get the hypertext if I want. Ball peen hammer. The face of the hammer, the head, is called the peen, and most of the time they're flat or slightly rounded for driving nails. A ball peen hammer has one peen that's hemispherical. It's round. Ball peen hammer is primarily used in metalworking. Has a flat face for striking and a spherical or hemispherical head for peening. And peening is the process of bending, shaping, or cutting metal by striking it with a tool or rivet heads. This hammer is also used for chisels and punches. In welding operations, the ball peen hammer is used to reduce stress in a fresh weld by peening or repeatedly striking the joint as it cools. So that's a ball peen hammer. Sledgehammers. These are for demo work. Sledgehammer is a heavy-duty tool that's used to drive posts or take on demolition work. You can also use it to break up cast iron or concrete. The head of the sledgehammer is made of high carbon steel and weighs between 2 and 20 pounds. You rate a sledgehammer, or you categorize it, by the weight of the head. So they were saying anywhere from 2 pounds to 20 pounds. A 10-pound sledgehammer is hard to swing, I'll tell you right now. And if you have one of these little 4 hammers, 2, maybe 3 pounds, you don't want to be ridiculous in the weight of your sledgehammer if you're using a small one like this, the short-handled one. Some of the guys will call this a Thor hammer. If they tell you to get the Thor hammer off the van, they're talking about the little one-handed sledgehammer. Sledgehammer can cause injury to you or anyone else working near you. Follow these steps to use a sledgehammer properly and safely. Wear the appropriate personal protective equipment, including gloves, eye protection, and safety shoes. Inspect the sledgehammer to ensure that there are no defects. Be sure there's no one nearby who could be struck on the backswing. Hold the sledgehammer with both hands apart, hand over hand. Stand directly in front of the object to be driven. Lift the sledgehammer straight up above the target, set the head of the sledgehammer on the target, and begin delivering short blows to the target and gradually increase the length and force of the stroke. If you're trying to drive ground rods, they're usually 10 feet long and you have to hammer them into the ground. If you're trying to drive a ground rod, don't have someone hold that ground rod with their hand. They can use a pair of channel locks, or you could even drill a hole in a 2x4 and slip it over the ground rods that you can hold it without your hands being close to the work. You're gonna miss. There's gonna come a time when you're gonna swing that sledgehammer and you're gonna miss that ground rod, and you could break someone's wrist if you hit it with a sledgehammer. So be very careful. And if you're the person holding the ground rod, don't hold it with your hands. Like I say, drill a hole, 3/4 or 1-inch hole in a piece of 2x4, and slip it over, and you can drive it that way. Warning, do not swing a sledgehammer beyond vertical and over your head. Doing so may cause a back injury and significantly reduce the control over the tool. So you really want to try to lift that head of the sledgehammer pretty much straight up and come straight down. You don't want to come way back behind you. Okay. Nail pullers, existing wooden structure often needs to be disassembled. Nail pullers and wrecking bars are tools for the task. So here's a nail puller. Here's a cat's paw. Oh, this one's a cat's paw. This is a chisel bar. This is a wrecking bar. The wrecking bar has a tapered end on both sides, and one of them is perpendicular to the handle. One of them is pretty much in line with the handle. Lets you get into tight places and pull out nails. 3 common nail pulling tools are the cat's paw, the chisel bar, and the wrecking bar. There are many other names used by craft workers to describe these tools. The cat's paw is a straight steel rod with a curved claw out on one end. It's used to pull nails that have been driven flush with the surface of the wood or slightly below it. The cat's paw is used to pull the nail head just above the surface, so another tool can completely pull it out. Cat's paw may lack the leverage needed to completely remove a long nail due to the tight curved head at the end. A chisel bar often has a claw at one end like a cat's paw, but the other end is flattened into a broad chisel-like head with a long bevel. Bevel is an inclination of a surface that intersects another surface at any angle less than 90 degrees. Also used as a verb, meaning to cut or trim an edge to an angled profile. Bevel. Chisel bar can be used like a claw hammer to pull a nail. The chisel-shaped end can be driven into the wood joints to split and rip apart the pieces or to get beneath the nail head. Sometimes those nails are driven flush with the wood or even a little bit countersunk, and you might have to take the cat's paw or the wrecking bar, and you have to put it pointed toward the nail, but be maybe 1/4 to 1/2 inch away, and hammer it so that it digs underneath the wood and gets underneath the head of that nail. Then you can get that nail out. So wrecking bars, also called ripping bars or wonder bars. There we go. I'm going to highlight that. Wrecking bar, also called ripping bar or a wonder bar. Have a nail slot at the end to pull nails. An angled wedge-shaped face on the other end is used like a chisel as well as a prying tool. All right, let me move on here. I think I'm taking a little bit too much time here. Here's a demolition tool. This is new. This is by Stanley. It's got you can pull nails with this teardrop opening. It's got like the cat's paw at one end, and it has very sharp edge on it for cutting into wood or to pry up nails. The Stanley Foobar, for example, combines the advantages of a pry bar with those of a hammer. 3 different striking surfaces allow the tool to be driven under or between parts for disassembly. It can be used to pull nails several different ways and can be used to chop through softer material such as drywall. So they're calling this their foobar. Safety and maintenance. Consider the following guidelines for the safe use and maintenance of hammers and similar tools. Make sure that the handle is set securely in the head of the hammer. Replace cracked or broken handles. Make sure the face of the hammer is clean. Hold the hammer properly. Grasp the handle firmly near the end and hit the nail squarely. Do not hit with the cheek or side of the hammer head unless the hammer has been designed for that purpose. Do not use hammers with chipped or otherwise damaged heads. That should be a highlight. Do not use hammers with chipped or otherwise damaged heads. Do not use hammers with a cast head. Never strike a hammer heads together. You also do not want to use any hammer that has a loose handle. If the hammer handle is cracked or loose, it needs to be taken out of service until the handle can be replaced. If there's nothing wrong with the head, you can always put a new handle. If the head is chipped or cracked, it needs to be discarded, throw it away. Following are additional considerations for the safety and maintenance of when working with sledgehammers. Replace cracked or broken handles before you use a sledgehammer. Use the right amount of force for the job. Keep your hands away from the object being driven. We talked about that before. Never swing until you have checked behind you to make sure you have plenty of clearance from both people and objects. Okay. Let's move on. Chisels and punches. You have wood chisels and cold chisels. They're not interchangeable. Don't use a wood chisel on concrete. If you use a cold chisel on wood, it's not going to hurt the chisel. It's just not going to do a very good job. Chisels are used to cut and shape wood, stone, or metal. Punches are used to indent metal, drive pins, and align holes. So chisels. A chisel is a metal tool with a sharpened, beveled edge. Wood chisels and cold chisels are presented in this section. Both types are made from steel that's heat treated to make it harder. Technically, a chisel can cut any material that's softer than the steel of the chisel. However, wood chisels are used exclusively on wood, while cold chisels are used on metal. The term cold chisel stems from the use of the tool with cold metal as opposed to metal heated by a torch or furnace. Both cold and wood chisels are manufactured in a variety of shapes and sizes to support specific tasks. Cold chisel has a more blunt end. I think that it has about a 60-degree bevel on the front of the cold chisel, while these wood chisels have a 45-degree bevel. So they're much sharper. They've been taken down to a razor's edge so that they can cut wood. These cold chisels are usually not sharpened to the point of being able to cut paper. You're going to be using them to cut metal or stone. So the blunt end of the chisel won't dull as fast as if you had beveled it at 45 degrees or even less. Cold chisels are designed for hard materials such as steel or stone. A flat cold chisel is the most common. Flat cold chisels have a tip around a 60-degree angle. They're often used to cut through bolts and similar hardware that's rusted or damaged and cannot be removed with wrenches. Okay. This is called a cape chisel. Cape chisel is manufactured so the cutting tip is slightly wider than the body. This feature keeps the chisel from binding in the cut when chiseling a groove. Cape chisels are used for cutting single grooves as well as cutting a series of parallel grooves when excessive material needs to be cut from a surface. Cape chisel. Before using a cold chisel, it's important to wear the appropriate personal protective equipment, especially proper eye protection. When you're using a cold chisel on concrete, there's going to be rock and debris flying from where you hit it. You need to wear eye protection. Don't let something get in your eye. If you were to cut a nail with a cold chisel, that nail could become a projectile and it could blind you. So you really need your safety glasses, and I would suggest maybe even a full face shield over the safety glasses. Let's see here. Let's go and see here. Stonemasons. Now, stone has always been an important building material. Because of its strength, stone has often been used for dams, bridges, fortresses, foundations, and monumental buildings. Today, steel and concrete have replaced stone as a basic construction material. Stone is now used primarily as a sheathing for buildings or flooring in high traffic areas for decorative uses. Okay. Let's see here. They're talking about wood chisels. It says to pare away the notched wood, hold the chisel bevel side down to slice inward from the end of the recess. Remember that most paring chisels should not be struck with a hammer. The palm of your hand can be used at times to lightly bump the chisel head. I would use maybe a rubber mallet or a plastic mallet. I don't know that I would want to use the palm of my hand, but here he's cutting out, I'm going to assume, for a hinge. Here's this hinge. So he's going to take the flat side of this chisel and he's going to score along the line that he's drawn with his pencil. And then you can see he's made several parallel cuts, just deep enough, like an eighth of an inch or 3/16 of an inch. And then he'll use this wood chisel with the bevel side down and knock, 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 knock. He'll take these little sections of wood out and make a nice little depression for this chisel to lay in. Punches. A punch is used to, uses the impact of a hammer to indent metal to start a drill bit, drive pins, and align holes in parts that are being mated. Punches are made from hardened and tempered steel. Tempered, it's tempered with heat to enhance or restore the steel's hardness. So if you heat steel to a high degree and then you quench it in oil quickly, it makes the steel very hard and brittle. If you let it cool slowly over time, then you end up with a softer steel. Chisels are usually soft steel and the hammers are hard steel. And you don't ever want to hit hard steel on hard steel because something's going to give, something will chip. So the cold chisels, even though they're being used to cut metal or stone, they're actually a softer steel than the head of the hammer. That way they don't shatter, they don't fracture. They will mushroom. And then you need to clean up that mushrooming when it becomes severe enough that it needs to be taken to a grinder and grind it off. Just clean it up. And the cold chisel can be used again and again and again. So here are punches. They're going to use, like they were saying, a lot of times when you're going to drill a hole with a drill motor, you'll use a center punch to punch a tiny little divot in the center of that hole, and it keeps the drill bit from walking when you're trying to start that hole. If you've ever tried to drill a hole in metal and your drill bit dances around on the surface of the metal and you can't get it aligned, that's what the center punch is for. Yeah. Give yourself a little indent for that drill to sit in. Okay. 3 common types of punches are the center punch, the prick punch, and the tapered or straight punch. The center and prick punches are both used to mark points on metal. The center punch is used usually heavier with a tip ground at a 60-degree angle. The prick punch tips usually has a shallower angle and makes a smaller impression. This is highlighted. It says the wider depression of the center punch makes it best for marking points for drilling, while the prick punch is best for general layout work on sheet metal. Okay. Safety and maintenance. Follow these guidelines for safe use and proper maintenance of chisels and punches. Always wear the appropriate personal protective equipment, including work gloves and safety goggles. Make sure that the wood chisel blade is beveled at a precise 25-degree angle so it cuts well. Ensure the cold chisel blade is beveled at a 60-degree angle. Sharpen the cutting edge of a chisel on an oil stone to produce a keen edge. A lot of people use a bench grinder to put an edge on their cold chisels. I would not suggest using a bench grinder for your wood chisel. It's too aggressive. It's going to take too much material off of that wood chisel. Inspect the point of the punch to ensure it's sharp and not damaged in any way. Punches can easily be sharpened with the proper bench grinder. Do not use a chisel, punch, or hammer with a head that has become mushroom. That's what we were talking about. Mushroom refers to the head of a tool that is struck or used for striking when the head becomes wider and distorted like the head of a mushroom. So here's an example of mushrooming. And you can take this to a bench grinder and you can grind off all of the mushrooming and return it to its original shape. Like I say, these chisels are a softer metal than the hammerhead, and it keeps them from shattering. But if you leave this mushrooming, eventually cracks will form, and these pieces can fly off and hit you. Warning, striking a chisel or punch that has mushroom-shaped head can cause metal chips to break off. These flying chips can cause serious eye injury. If a chisel has a mushroom-shaped head, remove the tool from service until it is repaired or replaced according to the company policy. One point 3.0 Screwdrivers. Screwdrivers are used to drive or remove screws. They're identified by the type of screw they fit. The most common screwdrivers are slotted, also known as straight, flat, or standard tip, and Phillips head. Specialized screwdrivers include the clutch drive, Torx, Robertson, Allen head, and all of which are designed to fit the head of fasteners with the same name. The three latter heads offer greater grip and allow more torque to be applied than slotted or Phillips screws without stripping the head. Torque is a rotational force, the rotating or twisting force applied to an object such as a fastener or the shaft of a motor. Also the turning force produced by a drill. As the bit's turning speed increases, torque decreases, and vice versa. And stripping is when you ruin the head of the screw, damaging or distorting the head or threads of a fastener. So here's your slotted or straight screw. Phillips is the plus clutch drive. Torx is the six-sided star. Robertsons are square. These are very popular for any kind of cabinetry when you're mounting it to the wall. They're very high torque. Your square driver has very little chance to slip out of that square hole. So they're very good at high torque installations. And Allen, we've seen Allen keys, they're hexagonal, they have 6 sides. Screwdrivers defined to fit common screws are described here. So slotted is a very common type of screwdriver. It also provides the least amount of grip on the screw head. Phillips is the most common type of crosshead screwdriver, often better grip over the slotted design. Clutch drive has an hourglass shape head that provides good grip, common where security from vandalism is desirable. Torx has a star-shaped tip, widely used for mechanical assembly and repair work, also popular in residential construction. So that's highlighted. The Torx head screws and screwdrivers, that's highlighted. Robertson is the square. It has a square drive that provides extra grip to apply torque. Like the Torx, the Robertson drive has also become popular in residential construction for both interior and exterior applications. And then the Allen is hex-shaped. It has 6 sides. Hexagon is 6 sides. That's highlighted. Screwdrivers and hex key wrenches Here are the handles. This is the shank, the handle, and the blade, and the different blades are what you use. That's a straight blade. These are Phillips blades. As far as I can see, these are hex keys or Allen keys. Proper use of a screwdriver. If you use the wrong size blade, you might damage the screwdriver or the screw head. I'm going to highlight that. That should have been highlighted. And here they're using a screwdriver that's too narrow. This one's too wide. This one's too thick. This one's too thin. So you want to get the proper screwdriver to fit the screw. Same with the Phillips. They have different sizes, 0, 1, and 2. You want to make sure that you're using the right tool for the job. 1.3.0, safety and maintenance. Properly maintain a screwdriver not only gives it longer life, it also helps prevent injuries. The following are guidelines for proper use and maintenance of screwdrivers. Keep screwdrivers free of dirt, grease, and grit so the blade will not slip out of the screw head slot, causing injury or equipment damage. Visually inspect a screwdriver before using it. If the handle is worn or damaged, or if the tip is not straight and smooth, the screwdriver should be repaired or replaced. Never use a screwdriver as a punch, chisel, or pry bar. Do not use or lay a screwdriver near electrically energized conductors. Do not expose screwdriver handles to excessive heat. Carry screwdrivers carefully with the tip down. Okay. That's tamper resistant. All right. 1.4.0, wrenches. Wrenches are used to hold and turn nuts, bolts, pipes, and similar objects that require leverage to turn. There are many types of wrenches, but they fall into two main categories, non-adjustable and adjustable. Non-adjustable wrenches include the open-end wrench, the box-end wrench, the ratcheting box-end wrench, and the combination wrench. So these are open-end. You can see why they're called open-end as opposed to the box-end that are complete circles or hexagonals. This is a ratcheting box end wrench, and here's a combination wrench. It has a box end and an open end, and usually if you have a combination wrench, both the open end and the box end are going to be the same size, a 1/2 inch, 9/16, what have you. These open end wrenches and these box ends, they usually have a different size. Like this side is 1 inch and this side is 15/16, just slightly smaller. 1/2 inch 7/16 is a common dual size for an open-end wrench. It's very convenient to have those two sizes in particular. Non-adjustable wrenches. The open-end wrench is one of the easiest wrenches to use. The open end allows you to position the tool around a fastener easier than a box end wrench, but with less grip. Most open-end wrenches offer two different sizes in a single wrench, such as 7/16 and 1/2 inch. Note that the metric equivalents are not offered in this context, as metric wrenches are sized by millimeter, and there's no functional equivalency between metric and imperial wrenches. These sizes refer to the distance between the flats of the straight sides of the wrench opening. This is highlighted. It says box end wrenches form a continuous perimeter around the head of a fastener. And sometimes they have 6 points, sometimes they have 12 points. Although wrenches with 12 flats offer slightly less security, the advantage is that there are 12 possible positions for the wrench to settle onto the fastener instead of just 6. In tight quarters, this is a significant advantage. Also, the 12-pointed wrenches can fit square nuts as well as hexagonal nuts. 1.4.2, adjustable wrench. As the name implies, you can adjust the opening of this wrench, so it's very versatile. It's a versatile tool. Adjustable wrenches, often called crescent wrenches due to the name recognition, are used to loosen or tighten nuts and bolts, as are non-adjustable models. Although a fixed jaw wrench is usually better and safer, an adjustable wrench offers a lot of flexibility in a single tool. In many cases, the two types are used together. For example, while a nut's being tightened with a box end wrench, the adjustable wrench might be used to prevent the bolt head from rotating with the nut. Here are pipe wrenches. They're adjustable and they have teeth on the jaw. This one is a smooth-jawed spud wrench. And you can see that the two jaws are parallel, where the pipe wrench, they're not. They're not parallel. And here's an adjustable, what we would call a crescent wrench. Crescent is one of the first companies to make this adjustable wrench, so we call it a crescent. Just like the Klein company made side cutters, so a lot of people just call generically any side cutters, they call them Kleins. Channel locks, that's a tongue-and-groove plier, but we call them, or a slip-joint plier, and we call them channel locks. To use an adjustable wrench properly, set the jaws to the rough size of the nut, bolt, or threaded pipe. Ensure the pressure, regardless of whether the hardware is being tightened or loosened, is applied to the fixed jaw rather than the movable jaw. I'm going to highlight that. Make sure that the pressure is on the fixed jaw rather than the movable jaw. Here's the fixed jaw. This is part of the handle. The movable jaw moves with this wheel. So when you're tightening or loosening, you want to be going in this motion. This would be loosening that bolt. If we wanted to tighten that bolt, we'd have to take this adjustable wrench and flip it over so that the fixed portion was on top and the adjustable portion was on the bottom, and then we could rotate it clockwise to tighten that bolt. You always want to use this adjustable wrench where you're putting the pressure on the fixed jaw, the one that does not move. Warning: improperly adjusted jaws could cause the wrench to slip, resulting in a loss of balance and serious injury. Whenever possible, pull the wrench toward you. Pushing the wrench away from the body is more likely to result in a loss of balance and injury. If you must push the wrench, brace yourself with your free hand. Gloves should always be worn when working with wrenches. Okay, and here's the spud wrench. The spud wrench has a tapered handle, and iron workers use spud wrenches a lot of times. They'll use this tapered handle to line up I-beams. When the crane is flying them in overhead, they'll get them lined up, and then they'll take this spud wrench and they'll shove it through the two holes in the I-beams so that they're aligned. They're lined up together. Where you have a column and an I-beam coming off that column, you're going to put your spud wrench through there, and then you can line up the other hole and put a nut and bolt through it. Tighten them up, and then take your spud wrench out and put a nut and bolt in that hole. That's a spud wrench. Definition of a spud wrench varies among the crafts. Rigid and others refer to the example shown in Figure 18 as a spud wrench. However, another type of spud wrench shown here looks like a common adjustable wrench with one end, while the opposite end comes to a blunt point shaped like a tapered punch. This wrench was developed for structural steel workers who need a wrench to tighten large bolts and nuts. However, before the bolt can be inserted through two pieces of structural steel or pipe flanges, another tool is required to align the holes. The spud wrench handles both tasks without changing tools. In some cases, the wrench is not adjustable, but an open end or box end style instead. 1.4.3 Sockets. Socket wrenches typically use a ratcheting mechanism that forces the socket to rotate in one direction. While it can freely spin when turned in the opposite direction. This enables the user to quickly tighten or loosen a fastener without removing and refitting the wrench after each turn, or when a complete revolution cannot be made because of poor accessibility. So here we have a highlight. It says, oddly enough, ratchet drive sizes are the same globally, and there are no metric drives. So while we have standard American English sizes, half inch, 3/8, and we also have metric. We have 14 millimeter and 12 millimeter and 10 millimeter. The drives are either 3/8 of an inch or a half an inch or 3/8 or 3/16, excuse me. They have to be universal so that you can switch out with standard metric sockets. So because they were developed in the US with standard size drives, all sockets have standard size drives. There are no metric size drives. So here's an example of a socket. We sometimes call this the ratchet. And these are the sockets that go on the ratchet. Here's an extension. Socket sets may contain different types of handles. The ratchet handle shown has a knob at the top used to change the direction of free rotation. Ratchet handles come in a variety of lengths. The longer the handle, the more leverage that can be applied. Larger hardware requires more torque, so handles are used with the largest socket and longer and stronger. This is a breaker bar. It doesn't ratchet. You can put a socket on it, and you can use it just to break a nut or a bolt loose, and then you can use a ratchet in order to continue taking it apart. Torque wrench. Okay, a lot of times we'll have to torque a nut or bolt to a specification. They might say 25 foot-pounds or inch-pounds. And it describes the amount of force put on a handle that far away from the bolt. So if you were a foot away and you applied a 20-pound torque, that would be 20 foot-pounds. Again, if you were only an inch away and you put 20 pounds on it, it would be a much lighter force because of the length of the handle, but smaller nuts and bolts are tightened to inch-pound rather than foot-pounds. So here's an example of a torque wrench, and like I say, a lot of things are specified as to how many pounds, inch-pounds or foot-pounds that they need to be tightened to. 1.4.4, safety and maintenance. Note the following safety and maintenance guidelines for working with wrenches. Pull the wrench toward your body, not toward your face or away from your body. Leaning into the wrench and pushing away can result in serious injury if the wrench slips off. Check the condition of the handle and jaw working surface before use. Keep adjustable wrenches clean. Do not allow mud or grease to clog the adjusting screw and slide. Do not use a wrench as a hammer. Do not use any wrench beyond its capacity. Never use a cheater bar or pipe on a wrench. Let's see what a cheater bar is. A cheater bar is a length of pipe or rod used to increase the leverage on a wrench or similar tool. The increased leverage provided by the cheater bar often exceeds the tool's capacity and strength, resulting in damaged tool as well as damaged work pieces. Tool lanyards. Tools are as important when working at heights as they are when working on the ground. However, when working at heights, a dropped tool becomes a serious hazard. If the tool has moving parts such as a battery-powered drill, a fall may destroy it. Almost any dropped tool can cause a serious injury or even death, especially when the impact is unexpected. So what we want to do is use tool lanyards. Tool lanyards specifically designed for work in an elevated environment have been introduced by many companies. Tethering tools to the tool belt or wrist when working at heights can prevent injuries, protect the tools, and eliminate the time lost to retrieve dropped tools. Here's a guy working up high, and he's got a tool lanyard here. Keep his tool from falling over the side of the building. 1.5.0 Pliers and Wire Cutters. Pliers are hinged tools used to hold, cut, and bend wire and soft metals. Pliers should not be used for tightening or loosening hardware such as bolts and nuts. If any significant torque is applied, they will round off the corners of the bolt or nut. Wrenches may no longer fit the damaged hardware properly, creating a larger problem. Here are different ones: Slip-Joint Pliers, Long-Nose Pliers, Lineman's Pliers. Those are our side cutters. Tongue-and-Groove Pliers, Locking Pliers. So here's your Lineman's Pliers. Those are your side cutters. Okay. These are Slip-Joint Pliers, and the Tongue-and-Groove Pliers, again, are the channel lock pliers. And this is a vice grip. It's a locking plier, so you can lock it onto something and it'll stay put. Slip-joint pliers. Slip-joint pliers are used to hold and bend wire and to grip and hold objects during assembly. They have adjustable jaws with 2 or 3 position. To use slip-joint pliers properly, place the jaws on the object to be held and squeeze the handles until the pliers grip the object. Adjust the jaw position to improve grip if necessary. Long-nose pliers are good for reaching into areas that are tight. Long-nose pliers, also called needle-nose pliers, are used to get into tight places where other pliers cannot reach, or to grip parts that are too small to hold with your fingers. They're also useful for bending angles or loops in electrical wire. Most have a set of wire cutting jaws near the pivot. I'm going to highlight this that says long-nose pliers, also known as needle-nose pliers. Lineman's pliers, again, these are our side cutters. Lineman's pliers, also known as side cutters, that's highlighted, have wider, heavier jaws than slip-joint pliers. They're typically used to cut electrical wire to hold workpieces. The wedged jaws reduce the chance that wires will slip, and the hook bend at the base of both handles allows for better grip. Tongue and groove, these are the channel locks. Tongue and groove pliers have serrated teeth that grip flat, square, round, or hexagonal objects. We're going to highlight that. They have serrated teeth that grip flat, square, round, or hexagonal objects. You can set the jaws in any of several positions by slipping the curved tongue into the desired groove. Large tongue and groove pliers are often used to grip pipe because the longer handles provide good leverage. So here's your tongue and groove pliers. These are made by Irwin. They're calling them vice grip, which they probably shouldn't, because vice grips are a different set of pliers. Locking pliers. The vice grips are locking pliers. Locking pliers clamp firmly onto objects like a vise. Due to the brand recognition, they're often called vice grips. They're especially handy for holding metal components together for welding or assembly, and for gripping a nut or bolt that has already been damaged. 1.5.6 Safety and Maintenance. Wear the appropriate personal protective equipment, especially if you cut wire. Hold pliers close to the end of the handles to avoid pinching your fingers in the hinge. Do not extend the length of the handles for greater leverage. Use a larger pair of pliers instead. Hold the scrap end of cut wire to avoid flying metal bits when you cut. Always cut at right angles. Do not rock the pliers from side to side or bend the wire back and forth against the cutting blades. Lubricate the pliers regularly to prevent rust and to keep them working smoothly. Never use pliers around energized electrical circuits. Although the handles may be plastic coated, they're not always rated to prevent electrical shock. Do not expose plier handles to excessive heat. Do not use pliers to turn nuts or bolts. They are a poor substitute for wrenches. Never use pliers as a hammer. Section 1 review. The type of hammer that is best choice for pulling a nail is the, I would say the curved claw hammer is the best type of hammer for pulling a nail. The rip claw hammer is used for pulling apart structures, wood, what have you, that has been hammered together. But the curved claw is good for removing nails. The cape chisel is made with cutting edge wider than the body, so it does not bind when chiseling grooves. Okay. And the type of screw head shown here is the Robertson. It's the square tip. When using an adjustable wrench, pressure to tighten or loosen should always be applied to the fixed jaw. The fixed jaw. Locking pliers are also commonly referred to as vice grips because of the company that made them.